so we are looking at Amantle's question. Amantle, your question deals with a circle, a tangent, and there's a few funny coordinate pairs on this diagram. So let's have a look at what the information is. They say, the diagram shows a circle with a center at O. Now notice O is the origin. So immediately we know our circle is x squared plus y squared equals r squared. There's no change away from naught, naught. Okay, then they say AB, this line here, is a diameter of the circle. Okay, it passes through the origin. The straight line, now ACD is what they're referring to. That line meets the tangent. There's a tangent here at the point B. It meets that tangent at the point D. The coordinates of B is 3 and minus 4. The coordinates for E is minus 3 and minus 8.5. And I've written that minus 8.5 in fraction form, minus 17 over 2. Okay, that's the information they give us. So let's start with the first question for 4 marks is the equation of, the coordinates of point A. Now, folks, those of you that watched last week would remember me telling you symmetry, symmetry, symmetry. It's a big idea in mathematics, okay? So if we have a diameter and that diameter passes through the origin, then the points on the other side of the diameter, there's some sort of relationship there, and it's a symmetry relationship. Okay, so by symmetry, I'm going to do this immediately, and I'm going to say by symmetry. Let's have a look. Here goes through the origin, so this point here, point A, let me just move the A up a little bit, and we have more space. The point A lies over there, and that point has coordinates minus 3 and positive 4. It's similar to rotating it through the center, through the origin, with the center of rotation, the origin 180 degrees. Okay, so not that difficult. Symmetry, the x values change sign, and so do the y values change sign in this case. Okay, that was a quick for 2 marks. Amantle, I hope you saw that. Number 4.2, they ask the following. Determine the equation of the circle that passes through the points A, B, and C. Okay, now look at this. A, B, and C are the points that lie on the circle. So if I draw in a little line that I don't need there, I just want to illustrate. That's exactly what we had in previous cases. There's a right angle there. Why? Because the angle in a semicircle is a right angle. Okay, so we know they say determine the equation of the circle that passes through the points. We know it's x squared plus y squared because the center is at 0, 0. What is it equal to? Well, the radius squared will be 3 squared plus this negative 4 squared. That gives you 16 plus 9, and that is 25. So the equation of the circle is x squared plus y squared is 25. Now, folks, there's information there. You just don't have just the equation of the circle. Put the other information in. Let's have a look where. OA is 5. The radius of this circle is 5. I have this as a 5. I have that as a 5. And yeah, that's what I can get from additional information from having the equation of that circle. But look at point C. Point C is the x-intercept. So this line running from there to there is also 5. And what will this be? This will be the point 5 and 0 because it's the x-intercept of the circle. Okay, let's read on. That was for 3 marks. Write down the length of the line AB. Now this is where it helps you to put the information on the diagram. Look at the diagram. We know that AB is AO plus OB. So we are not in the business of wasting time. For those 2 marks, we're going to say AB is equal to twice 5, which is 10 units long. It's twice the radius because it is a diameter of the circle. Okay, so that was so far for that little bit of, did I say, look at this, I didn't even put the coordinates down here. For this little bit of work here, we have earned ourselves 7 out of the 19 marks for this question. Basic stuff that you need to remember. Okay, let's look at 4.4. 4.4, they say, if it is given, now they give us the length of AD. Let's put it on here. This length, they say, is the square root of 125 units, that length. And they ask us, find the length of BD with reasons. Now, there's 3 marks here. So write a little bit more than just an answer. Okay, we know that this is a right angle. So we're going to argue from the beginning that ED is perpendicular to AB. The diameter is perpendicular to the tangent. Okay, that's why these 2 are perpendicular. Okay, or radius perpendicular to tangent, whatever you wanted to say there. Radius, diameter, same thing. Not really, it's half of the one thing is half of the other, but the idea is exactly the same. Okay, so look at what kicks in here, folks. We want this length over here. That length belongs to that right-angled triangle. So we immediately say that BD is equal to the square root of this 10 that's squared, and that's 100, plus 125 rooted and squared. That is, let me just move these 2 around. That's 100. Hey, let me delete that for now. There we go back. Okay, so that's the hypotenuse. So I should start with the root of 125 when it's squared is 125 minus this 100. Okay, and that gives us the remaining length, which is the root of 25, which we all know is 5 units long. So put that information on the diagram in case we need it. We know now that BD is also 5 over here. They wanted the length of BD. That was for 3 marks. That wasn't that difficult. Now we're moving to the next question for another 3 marks. Now this question again appears almost every year in the paper, where they give you a lot of coordinates a monthly, and they now pick a triangle that's right-angled in this case. There's 2 right-angled triangles here. Now remember, your metric geometry theorem comes into play here as well. Okay, so they can mix it a little bit with proportionality. But this case, they asked us for the triangle of ABD, the area of triangle ABD. They could have asked for ACB as well, or this little one, but they asked for ABD. We have that length, we have that length, we have a right angle. Now, what could be easier? Let me just remind you, to find the area of the triangle, you either have the area rule if there's not a right angle in there, or you have your rule that you learned from primary school days, half base times height, if there's a right angle, and that's the case here. For 4.5, and 4.5 weighs in at 3 marks, the area of triangle ABD is half base. Now we're going to pick the base. Let's pick the base as 10. So it's half 10 times the height, which is 5. And look at that. 50 halved is 25 units squared is the area of triangle ABD. Now, so far, I don't think anything in this paper was that challenging. So far, you have 15 marks in your pocket. Now the big one for 6 marks. Another circle, and here they go again. Another circle passes through A, B, and E. Now let's just investigate where is A, B, and E. Look at this. If I now join A and E, folks, can you see again? I'm in a right-angled triangle, and they're asking me for the equation of the circle through that triangle. So what do? I have the right angle on the circumference. It's the third question we've seen today with the same thing. So what do? The center of this line is the center of the new circle, and the radius of that circle, let's see if we have information on it. I don't think we have, so we have to apply a distance formula. Once we've got this center coordinates, just find the radius by, or you can work out the diameter of the circle and halve it. It's your choice.